Thank you and welcome everyone in 15th IEEE Symposium on Computer Application and Industrial Electronics. So I am MD Jilur Rahman. I will present a research paper here whose title is Simulation of Linear and Nonlinear Single Switch Single Input Dual Output Buck Converter. So I have divided my presentation in some parts. At first, I will talk about introduction, then single switch pseudo buck converter with linear inductor. After that, single switch pseudo buck converter with nonlinear inductor. So in nonlinear inductor, we will use 4665 nickel zinc. And after that, we will compare the linear and nonlinear inductor modeling for the CSS pseudo buck converter. So as we are proposing a new single switch pseudo buck converter, we will propose a new control strategy. So at first, we will talk about the introduction. So Malaysia has decided to reduce 45% of carbon dioxide. That's why they set a goal to achieve the 31% uses of renewable energy by 2025. So converter is the main element in the renewable energy production. So this is the conventional structure of the NEMO converter, where we can see they are using a single inductor, but they are using multiple switches. So we know that switches, as they are using multiple switches, their size, converter size will be increased, and as they are using a single inductor or shared inductor, there will be a cross regulation problem. So we are proposing single switch in the converter rather than multiple switches, so that the converter size will be reduced. And we are also proposing to use multiple inductors so that there will be no cross regulation problem. But the problem is inductor are the main bulky elements of the converter. So we are trying to reduce the components. So how we will use the multiple inductors, which can increase the converter size. So we are proposing to use ferrite core magnetic materials in the inductor of converters, so that we can operate the converter in a wide frequency range. We know that if we can operate the converter in a wide frequency range, so the inductor size will be reduced. As if we operate the material or the converter inductor in the wide frequency range, the converter size will be reduced. So we need to select the magnetic materials which are able to operate in a wide frequency range. So this is the linear model for single switch pseudo buck converter, where we are proposing to use a single switch, but they have a linear inductor. So we can see that as we are using single switch, although we are using single switch, the inductor, the voltage, the gate voltage, the diode current and MOSFET currents all are stable. So after using a single switch, as all are stable, we are getting stable results. So we can say that the pseudo buck converter with single switch can be a stable architecture of pseudo buck converter. So as in the previous this circuit, we have used a linear inductor. So we will use the nonlinear inductor in the same structure. We are adding and proposing a new method whose name is gyro capacitor model. So using this gyro capacitor model, we will test a new magnetic ferrite core magnetic material in the inductor of linear single switch pseudo buck converter, and it will be converted to nonlinear single switch pseudo buck converter. So this is the linear model, and we will use these three equations to convert the linear inductance into capacitance value, which will be the nonlinear. So we have selected 4665 nickel zinc, and this values we got from the data sheet of TDS Electronics. So we will use this data in this equation to find the actual capacitance value of 4665 nickel zinc magnetic metals. So we will get the capacitance value which will be used in this section in this part to evaluate these magnetic materials in the single switch pseudo buck converter. And we will use the magnetic material, we will use the converter in 5000 kilohertz, as 4665 nickel zinc magnetic material can offer 5000 kilohertz frequency. So this is the VH curve for the 4665 nickel zinc magnetic material. So this is the single switch pseudo buck converter where we are using Zioto capacitor model to test 4665 nickel zinc in this converter instead of using the linear inductor. So the main advantage is if we able to use 4665 nickel zinc in this converter, the converter will be operated in a higher frequency range. That's why the inductor size will be reduced and we will get the nonlinear behavior. So we will at first we will investigate whether this converter is operating can be operated in higher frequency range, and we will also investigate or observe that whether the converters inductor and capacitor diode currents are showing nonlinear behavior or not. If we can see that the inductor, capacitor, and diode current are showing nonlinearity, then we will be sure that the 4665 nickel zinc is working perfectly in the inductor of converter. So this is the inductor, cap, diode, and MOSFET current graph for the Zioto capacitor model or nonlinear single switch zero buck converter, where we can see that there have the nonlinearity in the inductor current as well as in the direct in the diode current. So this is the comparative insight between linear and nonlinear model. So this is the linear one, this is the nonlinear one. So the linear one is we got from this circuit, and the nonlinear one we got from this circuit. So in linear one, we can see that the inductor current is very much straightforward, very much straight. And in nonlinear inductor current, we can see that they have nonlinearity, and this have increased inductor current compared to the linear model. So we can say that 4665 nickel zinc is perfectly working with Zioto capacitor model, and we are getting increased inductor current as well as nonlinearity, and we can say that the frequency is operated in 5000 kilohertz, which is stable for this operation. So the inductor size will be reduced, and this is the more broad result for the comparative analysis of linear and nonlinear model. We can see that output voltages of linear and nonlinear models are stable, they're same. So although we are getting diode currents which was in linear and nonlinear model, in nonlinear model we can get the increased diode and capacitor current compared to the linear models diode and capacitor current. We can also see that in diode and capacitor there have nonlinearity, which values are increased than linear model, but the output voltages are same. That means we are getting stable output voltages or nonlinear and both nonlinear and linear modeling, as we have used same loads, same input voltages, same all parameters. So we are using same all parameters for linear and nonlinear modeling, but we are getting increased inductor, capacitor, and diode currents with nonlinearity. So which proves that our results are stable. So as we have proposed a new method, so we need a new control strategy. We are using voltage mode control using PI controller. So when we are using reference voltage S4, then we are getting nearly 40 volt, which means that this model, this control strategy is working perfectly. This is the output 2, where we have used feedback network 2. and then we are using nearly 20 volt. If we use feedback network 3, then we will use nearly 30 volt. If we use feedback network 4, then we. So if we use feedback network 2, then we'll get 20 volt nearly. And if we use feedback network 3, we'll get nearly 30 volt. If we use feedback network 3, 3.5, then we will get 35 volt, which is expected. So we have used single switch pseudo buck converter with linear model. Furthermore, we have also used single switch pseudo buck converter with non-linear model. We have used 4665 nickel zinc in the single switch pseudo buck converter with gyro capacitor model. Then we have got linear and non-linear results for the both converters. And as we have used same loads and input voltages, that's why we get stable output voltages, but we got the increased inductor and capacitor currents, and but stable output voltages. And we have also proposed voltage mode control using PI controller in the single switch pseudo buck converter, and it was perfectly controlled the output voltages for the both converters. These are the references of our slide. Thank you very much for listening us. Best of luck for everyone. Thank you.